All right, let's get straight into it. If you're prepping for your GCSE Computer Science Paper 2, you're in the right place. We're going to break down the absolute bedrock of programming from Section 2.2.1 of the specification. These are the core ideas you just have to know. Ready? Let's do this.
So here's our roadmap. We're going to start with the absolute basics, the core building blocks, how a program even remembers things. Then we'll get into how programs make decisions, how they get smart. After that, we'll see how to make code repeat itself efficiently, and finally, we'll run through the essential symbols, the operators that make it all happen. 4 key areas, all crucial for your exam.
First up, the core building blocks. You see, before a program can do anything cool, anything at all really, it needs a way to hold on to information. We're talking about a player's high score, a username, or the price of something in a shop. This is where variables and constants come in.
So what's the deal with these two? Let's make it really simple. Think of a variable like a labeled box you can store data in. The key thing is you can change what's inside that box whenever you need to, like a player's score that's constantly changing. A constant, on the other hand, is like a sealed, clear box. You put something in it once, at the very beginning, and that's it. It is fixed forever. You can look at what's inside, but you can never, ever change it. Think of something like the value of pi or the rate of VAT. They don't change.
Okay, so how do we actually get the data into these boxes in the first place? Well, we use a process called assignment. It's just the fancy official word for giving a variable or constant its value. So when you see a line of code like score equals 100, you are assigning the value 100 to that memory location you've called score. It is probably the most fundamental action in all of programming.
Now, pay close attention here, because this is gold. What you're seeing isn't just theory. This is the exact language, the exact syntax that OCR will use on your exam paper. For a variable, it's just a simple equal sign. For a constant, you'll see the keyword const right at the front. Knowing the difference here is non-negotiable if you want the marks.
Okay, so our program can store data. That's great, but how do we make it intelligent? How does it actually react to what the user does? Well, that's all about controlling the flow of the program, and our main tool for that is something called selection. So here's the bottom line. Selection is all about making choices. It's the if this, then that of programming. If some condition is true, the program does one thing. If it's false, it does something else, or maybe it does nothing at all. Think about it. If the password is correct, then log the user in. That's selection right there, and it's what makes programs feel interactive and smart.
And this is the structure you have to know for the exam. It always kicks off with an if and a condition, followed by then. You can check for other options using else if. The else is your safety net. It's what happens if none of the other conditions are met. And here's a pro tip. A really common mistake is forgetting end if. You have to use it to close the if statement and tell the computer, okay, the decision-making part is over now.
Let's move on to our next core idea. So we can store data and we can make decisions. Now let's get efficient. A huge rule in programming is don't repeat yourself. Writing the same bit of code again and again is just a waste of time and a recipe for bugs. That's why iteration, or as you probably know it, looping, is so incredibly important.
So how do you make a program do something over and over? Like, how do you get it to check every single item in a shopping basket, or count down from 10 to blast off? You're definitely not going to copy and paste the same code 10 times. No way. You use a loop, and there are 2 main types you'll need to master. Your 2 main options are count-controlled or condition-controlled loops. A count-controlled loop is your go-to when you know exactly how many times you need to repeat something from the very beginning, like display the first 10 square numbers. You know it's 10 times. A condition-controlled loop is for when you don't know. You just want the loop to keep on running while some condition is still true. For example, keep the game going while the player still has lives left. And again, here's the syntax straight from the exam reference. For count-controlled loops, you're looking for for, to, next. Perfect for counting from 1 to 10, for example. For condition-controlled, it's while and while. The code inside that block will just keep repeating, over and over, as long as that condition next to the while is true. The second it becomes false, the loop stops and the program moves on.
Okay, we're on the home stretch. We've looked at the big structures. Now we need the little tools that do all the hard work inside those structures. These are the operators, and I can absolutely guarantee they will be all over your exam paper. So let's make sure you know them inside out. First up are the comparison operators. These guys are the heart and soul of your if statements and your while loops. They compare 2 values, and the result is always either true or false. Now look really closely at that top one, double equals.
That is for checking if two things are the same. A single equals is for assignment. Mixing these two up is one of the easiest ways to lose marks. Please lock that in right now.
Next up, arithmetic. You know most of these already. Plus, minus, times, divide. Easy, but the two to really focus on are mod and div. Div just gives you the whole number part of a division. So 10 div 3 is just 3. Mod, or modulo, is the fun one. It gives you the remainder. So 10 mod 3 is 1, because 3 goes into 10 3 times, with 1 left over. Mod is brilliant for things like checking if a number is even or odd, and examiners absolutely love it.
And finally, the Boolean operators. These are what you use to combine multiple conditions. And is the strict one. If age greater than equals 18 and has ticket equals true, both sides have to be true for the whole thing to be true. Or is much more relaxed. If day equals Saturday or day equals Sunday, only one of them needs to be true. And not is the rebel. It just flips the result. It turns true into false and false into true.
So let's just pull this all together. When you see a big, scary-looking piece of code on your exam, don't panic. Just take a breath and break it down. I promise you, it's always just a mix of these three things: sequence, selection, and iteration. That's it. They use variables and constants to store the data and operators to do the math and the comparisons. Your key to unlocking it all is spotting these patterns and knowing that exam reference language.
Now, watching this is a brilliant start, but the only way to make this knowledge really stick is to actually write some code. So my question to you is, what are you going to practice first? Seriously, after this, open up your code editor and build a tiny program with an if statement, or try a for loop that counts to 100, or write something that uses mod to check if a number is odd or even. Go on, get your hands dirty. Good luck.